Have you ever seen an AI explain a meme and wondered, how? How does it get the joke? It's not just seeing pixels, it's understanding context and humor. Well, today, we're diving under the hood to figure out exactly how AI learned to see. So here's our game plan. We'll start with what these things even are. Then we'll look at the two big ways they're built, method A and method B. We'll check out who's using which, and then we'll pull back to see the bigger picture. All right, let's kick things off. What exactly is a multimodal LLM? And, why should you care? Why is this such a big deal for AI? Let's frame it like this, with a question that really cuts to the chase. What does it actually take for an AI to get a meme? Not just see it, but understand it. And believe it or not, this is real. This is happening right now. An AI can look at this picture and see beyond just cat and diagram. It understands the joke, the funny situation, the relatable feeling of being overwhelmed. That's a huge leap. And that's where we get our official term, a multimodal LLM. Modality is just a fancy word for a type of data. So instead of just understanding text, these models can process images, sound, even video. They're breaking out of the text-only box. So, how on earth do you teach a language model to see? Well, there are two main schools of thought. Let's start with the first one, which you can think of as basically teaching the LLM a whole new language, the language of pictures. This method is actually pretty elegant. First, you slice the image up into a bunch of smaller pieces, like a puzzle. Then, a special vision model turns each piece into a number, a token. These new image tokens get lined up right next to the regular text tokens, and the whole thing gets fed to the LLM as one long sentence of words and pictures. So here's the key idea. It's all about translation. You know how we break a sentence into word tokens? Well, this method does the exact same thing for an image, breaking it into patch tokens. It's turning pixels into a vocabulary the language model can finally understand. Okay, now for this second strategy. This one takes a totally different approach. Instead of translating everything at the beginning, this is more like having two experts, one for text and one for images, collaborate on a problem. The magic ingredient here is a concept called cross-attention. This is a mechanism deep inside the model that lets the image information and the text information talk to each other. They process things in parallel and constantly influence one another to build a shared understanding. And this side just nails the difference. Method A, the unified approach, is like a pre-made cake mix. You throw all the ingredients in the bowl right at the start. But method B, the fusion approach, is more like making a stir-fry. You cook the veggies and the proteins separately and then combine them in the wok, letting the flavors fuse together during the process. Okay, enough theory. How does this actually play out in the real world? Let's take a look at what some of the biggest models out there are actually doing. For instance, if you look at Meta's new Llama 3.2, they went with the fusion approach. A big reason for this is that it helps the model stay incredibly good at its original job, understanding and generating text. But then, on the flip side, you've got a whole bunch of other heavy hitters, especially in the open source world, that have gone with the unified approach. And why? Well, a lot of the time it's because it's just a simpler, more straightforward way to build it. This table gives you a fantastic snapshot of what's happening. You can clearly see the split. Llama 3.2 using Fusion, Mulmo and Quen using Unified. But what's really fascinating is the variety even within those choices. Some teams grab an off-the-shelf image encoder like Clip, while others are building their own from scratch. It just goes to show how much experimentation is going on right now. So this leads to the big question, right? With two different methods out there, which one is actually better? And as with most things in tech, the answer is, well, it's complicated. It all boils down to a classic set of trade-offs. If you want something that's simpler to implement, where you don't have to fundamentally change the LLM you're starting with, Method A is a great choice. But if you're worried about computational power, especially with high-res images, or if it's absolutely critical to protect that original text performance, then Method B starts to look really appealing. And really, that's the bottom line. Sebastian Raschka, who wrote the source material for this, sums it up perfectly. The main thing to know is that there isn't just one right way to build these things. It's a wide open field, and lots of different approaches are proving to be successful. So we've given AI the power of language, and now we're giving it the power of sight. It leaves you with a pretty exciting final thought. What sense is next? Are we going to teach AI to hear, to understand the nuance in a voice, or maybe something else entirely? The journey is really just getting started.